Hi students, we're going to look at the unit circle today. Now on this unit circle, it is called this because the radius is exactly 1 unit long. So if this radius is 1 unit long, and I was looking for, and this is the origin, I was looking for these 4 points, which are pretty important, I would call this point where the radius ends and hits the arc would be 1 on the x and 0 on the y. This point right here, of course, would be 0 on the x and 1 on the y if I had a radius that extended from here to there. If a radius extended from this point to this point, it'd be -1, 0. And this point right here is actually 0, -1. Now, that's easy enough. But what if I, let me get another color here, created an angle on the unit circle? Of course, my initial side would be on the x-axis, and let's say I made it look like this. This is not going to be to scale, and this is theta. And I asked you to find the coordinates right here for theta. Now you know the 0, at 0 degrees, your coordinate's 1, 0. But what is it right here at theta? Now to figure it out, you're going to do, well, let me stay with the same color. You're going to do this. You create a triangle. So I'm creating a triangle. My right angle is right here. Do not make the right angle in the middle. The middle is the adjacent for theta. And I know that this side right here is 1, right? Because it's a 1 unit circle. So the radius is 1, and that happens to be the hypotenuse of this newly created triangle. Now, if this is 30, it will obey this code of the 30, 60, 90. If the hypotenuse is 1, then the side that is across from the 30 has to be 1/2. So this right here comes in it, this has to be 1/2, right? And this would have to be 1/2. This is 1/2. This has to be 1/2 times the square root of 3, which is square root of 3 over 2. Now think about this. If this side is that long, square root of 3 over 2, that's the x-coordinate. And then it goes up 1/2. So it is root 3 over 2 for the x, because that's how long it is, and how high it is 1/2. Hopefully that makes sense to you. So what I need to show you now that this is cosine. When you're talking about x and y, and write this down now, when you're talking about x and y, x is your cosine and y is your sine. It's alphabetical. So if I said, hey, what is the cosine of 30 degrees? The cosine of, cosine of 30 degrees is equal to root 3 over 2. What is the sine of 30 degrees? Of 30 degrees is 1/2. All right, so let's make another triangle and see if I can bring another point to bear here. So let's make this a 45 angle. So I am measuring this, which is 45. I need to find out where the coordinate is right here at this point. And so I'm going to create the triangle again. I create the triangle with this x-axis, and I know that this is 45. And I know my radius is 1. Think about it. If the radius is 1, that's the c side. If 1 is equal to c, then 1 is equal to a root 2. Then a has to be 1 divided by root 2. But I can't leave it like that. I have to rationalize that denominator. So it becomes root 2 over 2 for the x and for the y, because they're equal, right? So this is going to be root 2 over 2, root 2 over 2. So if you ask me, hey, what is the sine of 45 degrees? I would say it's root 2 over 2. What is the cosine of 45? It is, again, root 2 over 2. Because this is a sine, this is a cosine. The first one's a cosine, and that is a sine. Let's do another. Okay, so now let's do 60 degrees. And again, this is not to scale. Okay, so if this is 60 right here, what are these coordinates? Now I know on a 60, now the hypotenuse happens to be 1, so the c is equal to 1. And we know the short side has to be 1/2, right? Because it's now crossing 30. If this is 60, this is 30. So I know the x is 1/2, and the y has to be the √3/2, because it's these two transposed. So if I said, hey, what is the sine of 60 degrees? The sine is √3/2. The cosine of 60 degrees is 1/2. So let's keep moving. Let's make, if we have a 90 degree angle, you don't have a cosine, right? Your cosine's 0. Your sine, and there's no angle. You can't have a 90-90 because your right angle has to be made over here on the x-axis. So that's why you have to have an acute angle. But what happens if you do have an obtuse? Well, we're about to see. What if you had 120? That would be all of the 90 and 30 more, right? Now you know that when you have a 120 degree angle right here, if you wanted to know this angle, you're going to have to find the reference angle. You come straight down. So while this is 120 right here, this is 60, correct? And you know if this is 60, this is the one, this is a short side, but it has to be -1/2 because it's going this way, and this side is √3/2. And notice it's just this point right here reflected over the y-axis. And if you reflect anything over the y-axis, you just change the sign of the x. So what if you wanted a 135 degree angle? If I make a 135 degree angle, then I have 90 and 45. And you're going to use this reference angle right here of 45 degrees. So you know the hypotenuse is 1. And so these each have to be √2/2 for the length. But the x is going in the negative direction, so the cosine is negative. And you can probably know, just by looking at this, if you made one more at 150, so if this angle right here was 150, this reference angle is 30, right? So if that's 30 and this is 1, this has to be the 1/2, and that's the y, and the x is √3/2. But it's negative. So it's not scale. But these, and we could keep going around, and we will in class, but we're already about at 8 minutes. But I'm going to ask you one question. I'm going to put 2 questions right here before I go. I want you to try them. And here they are. Using the unit circle, I want you to pause and see if you can find the sine of 45 degrees, and then find the cosine of 150. Okay, if you're looking for the sine of 45, here's my 45. The sine is the second one. It's √2/2. The cosine of 150, well, that had that 30, right? That reference angle. So right here is a cosine of -√3/2. And we're going to be doing that. It's going to take a little while to click. Here is the finished unit circle. And believe me, we are actually going to be memorizing this. I'll give you lots of practice memorizing it, but part of your test, actually, the first page is I give you the unit circle and you fill out the entire thing in its entirety. Actually, greater than this, because you're not only will you do degrees, you'll do it in radians as well. I know, working you to death. You guys take care.